Hey everyone, we're going to find a power series for the integral from 0 to x f of t dt. This is our f of x is 1 divided by x plus 2. So what we're going to do is first, let's look and see what we have. This is the interval of convergence. The power series is centered at, we look at this piece, x plus 1, and set this to 0. And we get x equals -1. So that means our power series is centered at -1. And we're going to let that a equal -1. So therefore, we need to find the power series for -1 to x of f of t dt. So we're going to integrate both sides of our equation here. So we're going to go from the integral of -1 to x, and we're going to write this as 1 divided by t plus 2 dt equals the integral from -1 to x, and now we're going to expand this. So when you expand this, you're going to get 1 minus, and then substitute in t plus 1 plus t plus 1 squared minus t plus 1 cubed plus plus, and then we have -1 to the n power times t plus 1 to the nth power, or the nth power, plus and then this is dt. All right, now we're going to integrate. I'm going to go ahead and integrate. Let's see if I can squeeze it in. This piece, so this is going to be ln of t plus 2, and we're going from -1 to x. And then for this piece, yeah, I think I can squeeze it in. The antiderivative of 1 is t. Then we're going to get -1/2 t plus 1 squared plus, for this piece, 1/3 t plus 1 cubed minus, for this piece, 1/4 t plus 1 to the 4th plus and then for this piece, this is going to be plus -1 to the nth power divided by n plus 1 times t plus 1 to the n plus 1 plus and we're integrating this from x to -1. All right, so we're evaluating it. Now, let's go ahead and evaluate it. I'm going to go ahead and substitute in my x and my 0, or my -1. So what we're going to get is, let's duplicate this. We're going to get ln of x plus 2. When you do the -1, you're going to get minus ln of 1. That just equals 0. So we just can write that. Now for the other side, we're going to get x minus -1 minus 1/2 times x plus 1 squared plus 1/3 x plus 1 cubed minus 1/4 x plus 1 to the 4th plus and then let's move it down a little further, plus this is, let's put here. We're going to get -1 to the nth. We're just copying down what we had, but substituting in for x. So it's going to be x plus 1 to the n plus 1. Notice when you substitute in, remember we had from -1 to x. When you evaluated it from -1 to x, when you substitute it in -1, you get 0. That's why we chose -1 for our integral. So it makes it easier. Now, this is going to equal the ln of x plus 2. And for this piece here, this is going to be the sum as n equals 0 to infinity. And you just copy this down. -1 to the nth power divided by n plus 1 times x plus 1 to the power of n plus 1. And our interval of convergence, again, is from -2 to 0. This is your answer here. Thank you. Have a nice day. Bye-bye.